Now let's move on to the second force, drag. Drag is the force that resists the plane's motion through the air. It's a type of friction. The amount of drag an airplane experiences depends on its shape and speed. As you can see here, a streamlined aerodynamic shape will have less drag than a bucky shape. When moving at the same speed, a smoother surface allows air to flow over it more easily. If both of these planes are flying at the same speed, the streamlined shaped plane will have less drag than the bulky shaped plane. What does that mean? A streamlined airplane moves through the air more easily because its surface is smoother, so the air flows easily over its surface. As the airplane flies faster, drag will increase. That's why faster airplanes have to be more streamlined. The relationship between thrust and drag determines the airplane's acceleration. When thrust is greater than the drag, the plane speeds up. When drag is greater than the thrust, the plane slows down. And when the two forces are equal, the plane maintains a constant speed. Here is a scenario. This jet is flying alone when its engine thrust suddenly decreases and becomes less than the force of drag. What will happen to the airplane speed? Will it speed up, stay the same, or slow down? Of course, the answer is it will slow down, because the force of drag is now greater than the forward force of thrust. The airplane will decelerate. Now next is the pilot restart the engine so that thrust increases and become greater than drag. What does the airplane do now? And the answer to our question is the airplane will speed up because thrust is now greater than the opposing force of drag. The airplane accelerates. While you think about that, let's look at the formula for drag. The drag force in the equation is denoted as drag force with a d as subscript. It's calculated as 1/2 times rho, which is air density, times the velocity square of the airplane, times the reference area, A, times the drag coefficient, denoted as CD, drag coefficient. The drag coefficient depends on the shape of the aircraft and its angle of attack, and is usually determined experimentally.